So 57.1.
Yeah, 11.1.
11.1. All right.
Yeah, 11.1.
Yeah.
Number 50.
All right. Oh yeah. Okay. Okay. So let me review my way to that point. Considering there are people that have no idea what that means.
You want to do the one before it? Number 40?
No, let's review a bit.
Would you rather do this one?
No, I'm not saying I'm not gonna look at it. Just say let's catch everybody up to what the idea is. So we looked at yesterday, just to do this a little bit quickly. A big part of what math does is it looks at patterns that happen, and then we try to develop a process to do things backwards very often, using that pattern. We noticed if you FOIL this thing out, you can double check me, you'll get this. X plus 3, x plus 3, 3x, 3x is 6x. So the middle number is going to always be twice this dude, because you're going to get two of them. That's amazing. And then how you get the last number is this thing times itself. Right? So this thing cut in half, will always be that guy. And then if I square that, what I get, it'll always be that guy. I say always. Let's double check. If I do x minus 5 squared, let me just write it out for everybody here. X minus 5 is minus 5. X squared minus 5x minus 5x plus 25. I get x squared minus 10x plus 25. So what is half of negative 10?
5. Negative 5.
Of course it is. I really want you to see. Of course it is. Right? Because that's, of course, where it would come from. Negative 5 and negative 5 is negative 10. So, of course, half of it's going to be this. And then if I square what I get this. Of course, because where would it come from? Negative 5 times negative 5. It would come from negative 5 squared. Yes?
Is this a faster process, or is there certain limitations to that?
Anytime I have something where it's x squared minus something x, I can always, always, always figure out what to put here to make it become something squared like that. That's really what I'm going to do. I'm going to do this backwards now. I'm going to say what, so I'm going to start with like this and say what would I have to add to this so that it factors like something squared. I like it. Why would I be... All right, so number one, you guys understand the main idea of anytime I write something squared and multiply it out, the middle dude is going to be twice whatever this is. And you can see that happening right there. It's going to, no matter what number I put there, would it have showed twice? Of course it would have. And then whatever that number I get when I cut this in half, squared is what has to be at the end. Because where would that number have come from? That number times itself. All right. I love the reaction. It's either I don't have a clue what you're saying, and yeah, I get that shit. Keep going. It's like nothing in the middle. Okay. It's the life of a math teacher, basically. So if I have something like x squared plus 12x, I want to figure out what to put here so that it becomes something squared like that.
Divided by 36.
Yeah. If I take the middle number, cut it in half, that's related to that thing we were doing earlier. I'm going to figure out what was here. So it's really weird. That first step tells you what the answer is going to look like. And the second step tells you what has to be here to make that work. So the first step is you take the middle term and cut it in half. That's what's going to go here. I already know this. And then the second step is you square what you just got. And that's what goes here. It's called completing the square. Let that be simple. It's not just a bunch of shit we made up and you got to do now. It's humans realizing how this stuff that we created works and then using it. Yes, sir?
So the AX itself, the middle term, will never cancel out. Or will it? I don't know.
It can't if it's there. So we can't let it cancel out because that's what I started with. There's a 12 there. I can't change that. That's what's kind of given to me to work with.
Okay.
All right. So now that we kind of see the process a bit, and I do have one that's more set of those from yesterday. If you need a copy, I think I have more back in the office. I just forgot to bring. So here's why I want to know how to do this. So this is completing the square. It's like, all right, that's kind of nice, whatever. On one level, it's kind of nice to be able to take all this shit and kind of condense it. And you're like, well, that still doesn't make me think it's a good idea. But we did that worksheet yesterday, and it said, how do I solve this? For example, what would I do to solve that? Whoever was here yesterday.
Square it.
Square root it.
Both sides.
The minute I put a square root down, I put a
Plus or
plus
minus.
or minus, so you capture both roots. That's the whole reason they had at the very beginning of that chapter was, what are the roots of this? And there's two of them, a positive one and a negative. So if you put the square root symbol down, you better put plus or minus. So would I put a plus or minus on this answer? There's the problem. Did you put a square root down?
Yes.
Did you?
No.
This is the problem I gave you. So which root am I saying I want? I'm saying I want the positive root because I didn't put a negative here. So the answer to this, of course, is 3. It's not absolute value of 3. That doesn't make sense. It's just 3. It's not plus or minus 3. We know the square root can't be negative. You guys with me? And that's not what this is saying, by the way. Is this? Some people say, well, I thought it couldn't be negative in the square root. But the original problem is, what do I square to get 64? There's no square roots in the original problem. Where did the square root come from? I put it to solve it. I undid the square. There was no square root to begin with. So yeah, the answer can be negative all day long. Does everybody see that? I'm trying to address all the concerns I know that come up.
Man-made root.
So what you're trying to say is that if you were to get 64 again, you'd just square either negative 8 or 8?
If say it again?
I said, if you were to get 64 again, you'd square either negative 8 or 8? Get 64?
Yeah, exactly. What do I square to get 64? I could square 8, or I could square negative 8. That's really why there's 2 answers. And really, 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 the reason there's 2 answers is because it's squared. Fundamental theorem says there should be 2 answers, right? Okay. So if I had this fundamentally is not different from what we just did here. That's the same problem. I got something I don't know squared equaling a number. Something I don't know squared equals a number. So how do I do that always?
Square both sides.
Square root both sides. You can see what I mean by these are not fundamentally different problems at all? Everybody starts to foil this out because you've sort of been programmed to do that. I'm sorry about that. But I'm not going to foil this shit out if I can get rid of the stupid 2. I don't have to foil it out then. So yeah, square root,
Plus or minus.
plus or minus.
Cancel.
It's my 7 equals
3.
plus or minus 3. So x equals 7 plus or minus 3. So what do I get? Don't circle that shit. What are my 2 answers? 7 plus 3, 7 minus 3. 4. And watch this. 10 minus 7 is 3. Squared is 9. 4 minus 7 is negative 3. Square, that's it, you get 9. Again, that's why you get 2 answers. Okay, maybe. Do you see what form this was in?
See.
This was in its final form. This was in something squared form, right? That's why I could do this. So if I had a problem like this to solve, let's see, nothing too ugly yet, Jeff. Again, on a test or quiz, I'll say solve this by completing the square, but also right now we don't know quadratic formula yet, officially. Right? So don't be telling me no quadratic formula on this. So what do I want to do? What's a little bit different from the stuff we're doing? I want to try to make that into something squared equals a number.
Minus 3.
Yeah, I want to get the 3 out of the way first, because when we were doing the completing the square stuff earlier, I had space to work with. I had a blank space. So let me get the 3 out of the way first. Spoil the 3. It's a rough day. Now you can do the process to figure out what goes here. Yeah, so the first step is cut negative 8 in half. Yeah, there. Thinking ahead. Now look, right there, I can write the next step. That's how this is going to factor. I don't even know what the shit that is yet, but I already know how it's going to factor. And of course, then I take, like a lot of you guys, I'm going to catch up to you. There's 16. You cut it in half. That's how it factors. You square it. That's what's got to be here to make it work. Where'd that shit come from? All the stuff we looked at earlier. It's just looking at the pattern of how things work and using that to our advantage. So I add 16. Better add 16 to both sides or else the whole thing is shit. And now what can I do that I've done that? This is the completing the square step. Completing the square. Square root. Now it's just like this problem was. That's the primary reason why that's useful. So it's square root. Plus or minus. X minus 4 equals plus or minus square root of 3. Can you do anything with square root of 13? Not a damn thing. 13 is prime. So I just add 4 and I'm done. Bam. Yes?
What's the prime number again? Try to refresh.
It can only be broken up as 1 times itself.
Okay.
And the other one's a composite. So 8's composite because it's 2 times 2 times 2. 7 is prime. This is only 1 times 7. There's no other nice whole number you can break it up to. All right. Now that there's some more people here, I want to stop for a second and give you something. Yeah, the back's got a little bit of a preview of stuff, but I don't care. I want to talk about the side with the brains on it. Yeah, brains. Zombie apocalypse is coming. I want us to be ready. Now, this is going to talk about, I don't know if anybody's ever heard of this before. I used to do this in my classes, and I sort of got away from it, but I have a feeling that I need to bring it back. All right. This is a real thing. This is not like what month were you born in, here's your sign, and it's bullshit. This is how your brain works. Now, some of you guys, you might not want to admit this, but a lot of you guys probably relate to a lot of the stuff on the blue brain side. Right? And a lot of humans do shit. It's just human nature to think that you're born into a certain place and you can't go anywhere. So there's a fixed mindset and there's a growth mindset. These two things exist. All right? And there's different levels of each one and so forth. And there's tests you can take online to see which one you are, but you pretty much know already once you read through these which one you are. So fixed mindset says intelligence is static. You're just born with a certain level of intelligence, and that's it for you. Right? That's the feeling. And it's not just because you're a bad person or whatever. It's just what you've been told. It's what you've seen. It's a lot of things that go into this. This leads to a desire to look smart. This is when people kind of do this thing at me when I'm asking, is everybody okay? Yeah, and inside they're like, I don't have a flipping clue what the hell you just said, but I'm just going to do this because I want to look like I know what I'm talking about. And I'm like, I'm going to see your grade later. I'm going to give you the grade. This horrible grade. And I'm going to know you don't know what you're talking about. Why would you do that? Because you want to look smart. And therefore, you avoid challenges because if you took a challenge and didn't succeed, you would not look smart. You give up easily on obstacles because if you try too hard, that's going to be admitting that you can't do it. You see effort as fruitless or worse. You ignore useful negative feedback, right? Like that's basically what I give you a lot of. You feel threatened by the success of others, right? Which is really silly. I mean, if there's somebody else in class that really knows their math well, you have no idea. Maybe this is their third time taking this course. Maybe they just took this course and they started again and they just decided to take a lower class than they placed into. They can do that. You have no idea. You can't make any assumptions about what it means about you based on somebody else's performance. Does that make sense? Now, if you have a growth mindset, and that believes that intelligence can be developed, just like you can develop muscles or you can develop cardiovascular health by doing certain things, right? Leads to a desire to learn, and therefore you embrace challenges because you know that's only going to make you stronger. You persist in the face of setbacks because you know eventually you can do it. Just because you have a setback doesn't mean you're not going to make it. You see effort as the path to mastery. You're able to do something, right? You learn from criticism. You actually accept criticism. You take out of it what you think pertains to what you're doing, and then you change things based on it. You find lessons and inspiration in the success of others. So if somebody else is doing really well, like, how are you doing that? What's going on? And they either say, I've taken this like 8 times, so I already knows a lot of this shit. Or they say, well, I'm doing this thing, I'm going to have a study group, I'm seeing this tutor, he's really good, whatever. Right? You actually find out what the hell he's doing. So there's been studies that show just learning that these exist will sometimes help people out. Because this just kind of makes you aware of how you're holding yourself back, right? So this is especially true when I give you like a little worksheet. I say, go ahead and try these problems out. I love the reaction. To me, I would be like, shit, yeah, I'm going to screw these the hell up, and I don't care because I'm not being graded on it. This is a fantastic time to make a whole bunch of frickin' mistakes and get them out of my system. Sweet, right? But instead I get, oh, no, you don't want me to let you practice? It's like, you're going to have this
give us the test right away.
yeah, you're going to have this bodybuilding competition, but I'm not going to let you lift weights before it. That sounds great. Yeah, I think that'll work out. Oil will make everything better. No. All right. So in the hopes that might help some of you, that's why I'm doing this. So, a lot of where you are right now with math is a little bit out of your control, but where you go from here with where you are in math is completely in your control. So you might have had a teacher that set up incorrect expectations. I've had people tell me the practice test was the exact same as the actual test, which is complete bullshit. That doesn't help you show or try to live up to being able to show what you know. No, just memorize all the answers and put them all down. That's not math. That's not how this works, right? Anyway.
There's teachers that actually do that?
Oh, God, yeah. Yes.
Oh.
And when the student told me that, I was like, no way. And then I actually saw it firsthand.
Oh, shit.
I had to evaluate some teachers, and I actually I got a copy of their test, and then I had a student show me a copy of the practice test, and they were the same.
Oh, hell no.
Yeah, and some of you guys are like, who is that person? And that's freaking fixed mindset. This is just a hoop I got to jump. Math is a little checkbox I got to check off, and then I can actually get my degree. Well, that's bullshit. Math is obviously important, not just because math people have a good union and we argued it, because humans developed it for certain reasons, right? So you should know math. You just know it. Math gets a worse rap than English, though. If you don't speak good, then it's a little bit worse on you. If you're not good at math, hey, I'm part of the club. Kick ass. It always kills me. Anyway, any questions about this mindset business? I actually have a different one that's got like the fixed mindset is the dark side and the growth mindset is Yoda sitting there telling you. But I thought that was a little bit too geeky. Yes?
I found a certain quote interesting. This quote says, if you ask questions, you may look like a fool for a minute, but if you don't ask questions, you'll be a fool for the rest of your life.
Exactly. It's not about what you look like. It's about substance, right? And I think more and more nowadays, it's been true for a long time, but people are so worried about their image, they don't care about what they actually do, right? You can't control what other people think of you. You can only control what you think of yourself and what you do, right? All right. I'm not a life coach, so I'm not going to try to step into that role. But there are things you could do, things you could be aware of that will help you with some of what's holding you back in math. So I wish I would have done this like the first day, but it just sort of slipped my mind. And then I'm like, oh yeah, I got that mindset thing. Maybe this will help some people out. Hopefully. Okay. All right. Enough of that. Unless there's another question or anything. All right. Yes?
Can you give us some practice questions on
Yeah. Okay. So let's do all right, let me give you a nice one to work out, just as a practice, and then we'll do a gross one, even worse than what we did yesterday.
This will all be from 11.1.
Yes. I want you to realize something about all the problems we've done. that this has been a 1 here. So we still have to talk about what to do if it's not a 1.
God. That's when you get to use the quadratic formula, right?
Nope. What the shit?
Or not.
So solve it just like we just did a minute ago. You can't factor that thing. If you're able to, please show me. Teach me. This is not factorable. While you guys are doing that, anybody here right now didn't get their test back from? Curved a little bit. You can change right now to that. It'll help me out if you make corrections. Just cross through that, put that. That's your actual. Because it curved it a little bit. Everybody else has their test. Oh, I mean. Same thing. Curve it a bit. Just cross through that, put that curve down. If you make corrections, that would make it easier for me. Right. So, curve it a little bit. Cross through that, put that right there. Okay. Is that everybody? All right. What's the first step here?
Add 11.
You make some room. I like it. Yeah. So you cut 4 in half, and then you
Square.
square it. So this tells you how the next step is going to look. It's x positive 2. And this tells you what? Yeah,
Add 4
up
to each
here,
side.
to make that true, you add 4. If I put it on one side, I better put it on the other side. I always get somebody that's like, why would I put it over there? It doesn't need it. I'm like, you don't have the option. If you change one side, you got to change the other side, or else it's not true anymore. So here I get, cool. And now I'm at that same step. Square root.
Plus or minus.
It's like I am root. I like it. Subtract 2, so then you end up with -2 plus or minus. You normally put that number, just put it out front. It's better to have that plus or minus in the middle of things so it doesn't get lost or confused. The little thing. All right, so let's try. I told you ahead of time, this is going to be gross. We're going to do this one together. 3x squared. You write, use a pen that works. 3x squared, there you go. Oh yeah. Get some high stuff on there. Minus 5x, so this is going to be really gross. I like it. Plus 7 equals 0. So if you try to see if you can factor it, you can't. 3 times 7 is 21. 3 and 7 don't make 5. 21 and 1 don't make 5. I ain't gonna factor. Can't use quadratic formula because I've already shown it to you yet. But completing the square only works if that is a 1. It's kind of like how it's hardwired. That's why it works relatively easily, is that must be a 1. So how do I make that a 1? Divide by 3. So you got x squared minus 5/3 x. And I might as well subtract in 7/3 over, get it out the way. Get out the way. All right, now here's where everybody just kind of gives up. The steps, now of course the steps don't care, but the steps don't care what's there. They're always the same steps. I'm just going to write them in a way that makes more sense to me because there's freaking fractions in there, right? What's the first step? You complete a square. Use a. What's the first step?
Isolate it.
What do you mean? No. Right, I got everything in the way it's supposed to be. Like here, what did we do? We had this. What did we do? We cut the middle thing in half and then we squared it, right? I mean, that's the heart of completing a square. A lot of you guys don't believe we have to do that because you're like, wait a minute, there's a gross number in there. I don't care how gross the number is, I can cut it in half. It'll be half a gross. So how do I cut -5/3 in half? I divide by 2, but what's a better way to do that when there's fractions? Division by 2 is multiplication by 1/2. Now, see, I already can tell a lot of you guys might be looking this way, but you've checked out. Because you're like, those fractions, screw that. I'm just not going to do those. I'm still going to pass. Haha, Mr. Waller. Yes?
I thought you multiply it by 3 and then cancel it out.
Where's the balance? You're working with the number -5/3. If I multiply by 3, that must mean I have another side to do that to. There must be something that I'm balancing with, or else I'm just saying, I don't like that number, let me make it a different one, which I'm not allowed to do, right? That 3 came because I needed a 1 here. If I multiply by 3, I'm right back to where I started, and then complete a square says, I can't work with that. So I have to work with this number. But dear God, how hard is this? How hard is this? -5/3 times 1/2 is -5/6. Not difficult. And then what's step 2? You take what you got and you... What's the second step? Square
Multiply
it.
by 2.
The steps don't change, right? Really bad, Shakira's. The steps don't change. You square it. How hard is that? What's -5 squared?
25.
25. What's 6 squared?
36.
36. Do you like how those look? No. Were they hard to get? No. So then should you give a shit that they look bad? No.
Let's put the inside.
Every step so far has been easy. It's the same steps we did before, just with ugly numbers, who cares? So what do I put here?
25.
Yes, 25/36 goes there. And it better go over here. Stay with me. And then what does this tell me? What does that tell me? Same thing it told me over here. The next step, it tells me how it factors, right? I mean, can you see how the steps are the same? Yes, there are fractions, but I'm just moving them around right now. How hard is that? Put the 5, 6 over here. Oh, it's a fraction. Oh, who gives a shit? Just put it there. Right? So what's the next step? It's going to be x minus 5/6. That step always tells me how it's going to factor here. Now, the hardest step in this, the real only place you have to do something with the fractions is right now. On that side of what I have to do.
You have to
Find LCD. How hard is that? Yeah. Times 12, times 12. So I get -84/36 plus 25/36. So what do you get there? 59. Right? You guys still with me? Or you guys with me? Period. Every step we did before that one was exactly the same. I was just moving stuff around. I put a 1/2 next to a fraction. I multiplied the top and the bottom. 3 times 2, not hard. Then I squared the top and the bottom. Not hard. Then I wrote them in the right place. Same place I wrote the other shit before. Not hard. Now, LCD is not hard, but yeah, that's the part I know that some of you guys hate, but oh well. You got to know how to freaking put fractions together. Not hard. And then what's the next step? 2 more steps and I'm done. Square root. Plus or minus. So you get, there, parentheses. You get x minus 5/6 equals What's the square root of negative 59? There's only one thing I can do with that. What's the square root of negative?
Positive.
I. And 59, can I break that up? No. And what's the square root of 36? 6. And then I just add 5 6 over, and I'm done. I didn't have to do much at all with those fractions. They just sort of came for the ride. The only thing I actually had to do mathematically with them was LCD. Everything else is just following the pattern of what completing the square says. Now, please try to see that. That looks a lot worse than this did, but that was not that much harder than this was. Step by step. Okay. Step by step.
For your first step, would you always, when you're dividing 5/3, would you always times it by 1/2?
Oh, so we divided by 3 just to make a 1 here.
No, one.
And then
Yeah,
whenever, this first step is whatever's in the middle,
yeah.
cut it in half.
Oh,
You can either divide it by 2 like we do with whole numbers, but that's the same thing as multiplying by 1/2, and that's a better way to write it if it's a fraction. Yes?
If you did use the quadratic formula on that equation, you'd get the same answer?
Of course.
Okay.
Because quadratic formula is sometimes a shortcut to this, sometimes not.
Just,
Now, real
I'm
quick.
just curious.
Real quick, completing a square, this is only one thing it does. So you're like, well, if we invented quadratic, why do we still have this shit? Because this shit is still important. It's not the only thing it can do. It does other things for us. So this idea of completing a square is necessary. It's also what proves quadratic formula, which you're going to do in a minute. It's where quadratic formula comes from, is using completed square. So yeah, this is kind of important. How we feeling about this? Yes.
I just had a question for when you put x minus 5/6 squared, that's because it's going to be two of the same thing. And when you factor, it's only when you do the negative and the positive.
Yeah, right here, what was the result of the first step? Negative 5 6, so that's exactly what goes in here. Why? Because that's the pattern we observe to create this process. Whatever the middle thing is, half of it is what was here, and then that squared is what must have been there to make it work. That's the process. It works the same way no matter what the thing in the middle is. If I put a letter here, it worked the same way, which we're going to look at in a minute. You thought this was gross. Wait till it's A, B, C instead of 3, 5, 7. Okay, all right. So, let's do that right now. Keep talking about it. What time is it? Oh, it's early still. Are you still going? Poor little dude? Yes.
Is this going to be 11-2?
I forget. Students are always like upset at me because I sometimes forget to tell you what section I'm in. All I'm doing is got this idea, and then this idea, and then this idea, and then this idea. Yeah, 11-2.
All right.
Okay, so to be honest, I think everything I'm about to do is in the book already. You don't have to write these notes down. You don't have to be able to do this on your own. But I do want you to go through the experience of seeing where quadratic formula comes from. It wasn't just something math people went, yeah, negative b sounds good. You gotta throw a plus or minus in there, make it interesting. Square root in there, make some shit weird. No, it's got to come from somewhere. All right. So where it comes from is you start with this, which is the most general representation of the problems we were just doing, right? I could have made this number anything, this number anything, this number anything. Okay, except 0. 0 here would make it not make too much sense. Okay. So who remembers, when I had a 3 here, like right now I got an A there. What has to be there for completing a square to work? 1. So what did I do to get rid of that A? Divide by A. I like it. Like, what the shit? There's already letters, no numbers, and you're making it fraction letters. So what the hell? Oh well. Let me go ahead and subtract that c over a over just to make room, right? That's the next step, make some room. Again, you don't have to write this down, it's in the book. Unless you want to write it down, it's up to you. I'm not going to slap it out here. Stop right. Now, is it in the right form to start doing the 2 steps for completing a square?
Yes.
Totally. Is it in the form you wanted it to be in? No. But you don't care. What do I do? What's the first step?
B over A times half.
Yeah. Cut b over a in half. What do you get?
B over 2.
b over 2a. That
Oh
should
my
seem...
God, no way.
And then what do you do to this for the next step?
Times by itself.
Yeah, b over 2a squared is b squared over 4a squared. Okay. Right? And again, bless you. I'm not changing the steps at all. Steps can't change. They can't. As a human, I'm concerned that there's letters and there's fractions, but doesn't mean steps don't care. So what do I do with this guy? Let's start there.
Add it to
That's what I have to add
To both
to
sides.
both sides to make things work. So this sounds like a noble thing. Let me make things work. And then what do I do with this guy? That is how what does what.
That's how you get your equation.
Yeah, that's how this factors. X plus, you can't write like normal, Jeff. Don't be doing that shit. B over 2a, right?
Squared.
Squared equals. Okay. Now here's where some of you guys, well, if you haven't already checked out, some of you guys might check out a little bit, but stay with me now. It's not that hard. Before I can put these together, I need common number. So what number does this guy need?
4.
A 4, of course. And then he needs how many more a's?
1.
1 more a. Okay, was that hard? No. So multiply by 4a, multiply by 4a. And I get, let me write it this way. Is this cool? B squared minus 4ac, all over 4a squared.
Yeah.
Sounds familiar. Hopefully it sounds familiar. And now I've got it in the right form to do what? Square root. The minute I'm done with completing a square step, I should have it in a way I can square root it right now. I can kill that square. Square root,
Plus or minus.
plus or minus. So I get x plus b over 2a equals plus or minus.
Square root.
What's the square root of 4a squared? 2a. And what's the square root of this shit? I have no idea. Don't start doing weird shit. It's a minus. Square root can't do parts of a minus problem. Just got to put it over the whole thing. And then the last step, of course, see how these already have like denominator? So if I subtract that over, I get negative b plus or minus square root of b squared minus 4ac all over 2a, which of course is the quadratic formula. That's all quadratic formula is doing completing the square to the most general situation, because then you can just throw in what the a, b, and c happens to be. Yes?
Where's the negative b over 2? Where's the 2?
Negative b over 2a plus or minus this over 2a. They have the same denominator, so I just put them together.
Okay.
Yeah, so it's negative b over 2a. See, there it is.
Okay.
Plus or minus that over 2a. It's just condensing what I'm writing. Yeah. Now, obviously, if you don't already have this memorized, you have to have this memorized, right? And it's not the most damn important thing in the whole universe. It's just the thing that gets picked on all the time. What the shit do I need to know this for to go buy gas? I'm like, this has got to do with buying. So let's do that one we just did. What the one that had a 3 in it? That Will was like, can I just do quadratic? 3x squared, what was it? Minus 5x plus 7? Was that the one?
Yeah, something
Yes?
like that.
Minus 5x plus 7? Is that the one it was? Yeah. Okay. So let's go ahead and try to use quadratic formula on that. In this situation, what's A?
3x.
3. What's B? Negative 5. And what's C? 7. So it's just a plug and chug situation, right? That's the power of quadratic. It did all the steps with just a general ABC, and if you know what A, B, and C are, you can plug them in. Let's see if we get the same answer we got before. Some of you guys are still just staring at me. This is not good. You still need to plug in the values of A, B, and C in the right place, and then simplify it. Do it. Some of you are just staring at me still. All right. I can only do so much. What are you trying to do in your head? That's a neat choice. I like that. That's it. Oh, that's from before. That's right. That's for a while. Kevin. Kevin's not here. Rizella. Oh, he's in here. Correction, so. Ricardo. All right, so let's see. So x equals negative b, and b is negative 5. Negative 5 is 5, plus or minus, square root, b squared,
Oh, that's right.
Minus 84.
minus 4 times a times c. Is that cool? Times 721. All over twice a. So we get 5, give or take, 25 minus 84. Remember, there's that familiar looking thing there.
Over 6.
Over 6. 5 plus or minus I rad 59 all over 6. If you look back in your notes, it's the same thing we got before.
So what, I know this is redundant. So for the 5, I isolated the 2a alone. I got 5, 2 times 3, plus or minus, square root, blah, 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 2 times 3.
Oh, I see. So you got 5 over 6
Yes.
plus or minus this over 6, which is the same thing as this.
Yes.
Yeah.
Could you write it that way, though?
Yeah,
that's
totally.
one.
Of
course.
Okay.
And to be honest, in a way, it's a better way to write it because it's
Yeah, that's the way I prefer to write
A
it.
plus or minus BI. That's the form of a complex number. Yeah. So it's
Okay.
either way, it's fine. They're both the same.
You know, like that.
Perfect.
If you ever have a teacher that has a preference for one or the other, it's like, how picky are you with other things? Shit. And of course, that's part of your definition of math teacher, I think, normally is picky. All right, good. So those of you that were waiting for the day, you could use quadratic. There you go. Now, of course, you know I'm going to say,
We have other
solve using
quadratic
completing the
formula.
square on at least one problem somewhere. Because I have to. You need to know completing the square. All right, so let me give you this. On the back of the brains is all the ways of solving quadratic equations, all right there for you. That kicks ass.
Light.
And I want you to use that to help you do this.